Now we are going to introduce. Now this is basically an introduction to Numpy. Let's start. Why are we using Numpy? First question. So Numpy basically helps in effectively loading, storing, and manipulating in-memory data in Python. For example, we have digital images. Digital images can be thought of as simply two-dimensional arrays of numbers representing pixel brightness across the area, or the sound clips or music can be thought as one-dimensional arrays of intensity versus time. So, for this reason, storage and efficient storage and manipulation of numerical arrays is absolutely fundamental to the process of doing data science. We need to understand how the data is processed in Python and how it is effective in terms of manipulation, in terms of storing the data, in terms of those are basically two things which we care about most, while how it is handled, how the data is handled, how efficient it is, and that's it. So understanding the data types in Python. So for the data types, we have dynamically typed languages, example Python. So in dynamically typed languages are those languages in which you don't need to explicitly provide the type of the variable that you are using. For example, here if you're using a variable which is x, so you are actually not defining int as here, which is a static type language, for example C, C++, and Java. So here what you need to do, you need to explicitly define an int such that to tell the compiler it is an integer variable. And same goes with string. You need to explicitly provide your compiler that this is a string x and which holds the value hello. In dynamically type, it is flexible in this term. So this flexibility of dynamic typing comes at a cost. A Python integer is more than an integer. Okay, basically it's an object, and it's an integer object that has some overhead. Overhead it has, the overhead that I'm talking about is OBREFCNT, which is basically a reference count, an object type. What is the type of the object, whether it's integer, whether it's string. So, and object size, how much size does it have, and how many object digit is basically represents the digit of the object, as the name suggests. Object digit is basically which contains the actual integer value that we expect Python variable to represent. And reference count, which is ob underscore refcnt, a reference count that helps Python silently handle memory allocation and deallocation. An object type which encodes the type of the variable. So python list, okay, focus on these three mmc of Python list is something, if you're using Python, you have to know about the Python list. Without this, I don't think you will ever be able to understand the data science. Not even data science, I'm talking about regular Python. Like, it is the container in which you hold different elements. Basically understand this, and I'm gonna take a little bit of time here. Python list is a mutable multi-element container of Python. It is mutable such that it can be changed. It has multi-element, it can contain different data types in it, and it's a container. Basically it holds everything all together and provides you access, storage, deletion, everything. And this is the foundation of data storage for Python. Now let's understand about the fixed type of arrays in Python. I'm going to code it. Let's get started with fixed type arrays in Python. So I'm going to import a module which is array. Using array, I'm going to define something, let's say ARR is equal to list, which has certain values. Let's say I'm taking values from 0 to 9. So I take the range 10. And now what I do is I call the array. Uh, let's say I have another variable which is L, or maybe the one I would like to. Okay, so I'm gonna name it X. It doesn't matter. Just for the reference purpose, I'm naming it so that people are able to understand. So X is a variable which holds list of values ranging from 0 to 9, including 9, excluding 10. Now I'm going to create array using array library. So I'm going to call array, and I'm going to pass the data type which I want, which is I, because when we try to do something of a fixed type, it takes less memory, and it is almost like a static typing of coding that we are doing right now. So I and another parameter which I'm gonna pass is X. Now let's print X. So it is a list. Now let's print array, and it should give me an array of data type which is integer, and it has values. It has got values which range from 0 to 9, including 9. Now let's see what if we don't use an integer. So what if we append a value other than integer? For example, let's append hello, see if that works. It should give me a type error. An integer is required, got type string. Now next which I'm gonna do is array dot append a floating point number, let's say 1.25, and for this too it should give me a type error, which it would be asking integer argument expected got float, so it won't be adding that to the array itself. So this is what fixed type arrays in Python. We will be creating arrays from Python list using Numpy. So first thing that you need to do is import Numpy as np. This is a common convention. It is the short form. And the next thing what you can do is you can use np.array method, and you can pass in any array. Let's say 1 2 3 1 2 4 5. Okay, and I'm gonna give it a variable. I'm gonna store it in a variable, let's say X, and let's print X now. So it is giving me 1 2 4 5. Now I'm going to print what is the type of X. What is the X type? So type of X, it should give me a numpy, which is of n-dimensional array. Now remember that unlike Python list, numpy is constrained to arrays that all contain the same type. If types do not match, numpy will upcast it if possible. Here's integers upcast to floating point. So what I'm going to do is I'm going to use this np.array, and I'm going to put some 1.1 floating point, and rest others will be integers. And let's see what happens when I call this out. I'm gonna keep it in a variable named y, and I'm going to print y. Let's see what happens. So it actually has done upcasting for me since we have one floating point number which is 1.2. So it has upcasted the it has upcasted the integers to the floating point numbers. So that's what is one of the good things about NP array. It helps you in upcasting. And the next thing that I would like to basic array manipulation. We will cover a few categories of basic array manipulations. The first is attributes of the array. Attributes of the array include determining the size, shape, memory consumption, and data types of arrays. The second is indexing of arrays, getting and setting the values of individual array elements. Third is a reshaping or slicing of array. So I have missed, like, there is another point which was going to be added in the PPT which is missed. So it's okay. The reshaping of array. One more that I have missed in the PPT is slicing of array, and the last is joining and splitting of arrays, combining multiple arrays into one and splitting one array into many. That's the last part. Let's get started with the attributes of the array first. Discuss some useful array attributes. We will start by defining three random arrays. One would be one dimensional, the second would be two dimensional, and the third would be third dimensional as follows. So first thing that you need to do is import numpy as np, and second thing that you need to do is np dot random dot seed. You have to call the seed method from random, and you are going to set it to 0, which will allow to set values, which will allow to ensure that the same random arrays are generated each time this code is run, because we need to sometime we will be executing the code again. So it might happen that the random values that are generated, those are random, right? So they might change. So we want the same random arrays to get generated each time the code is run. So we are going to do seed is equal to we will provide seed with a 0 parameter that will ensure that to ensure that same random arrays are generated. So let's get started with creating arrays. uh, x1 is equal to np dot random dot randint. I'm going to call the randint random integer, and I'm gonna set the size is equal to 6. Okay, so it will give me six such elements. Okay, so this is our one dimensional array. The second is our two dimensional arrays, which we can get by np dot random using the same randint, and it will have that's the high value that we can set, and size is a two-dimensional one. So size I can set as 3 comma 4, which is 3 rows and 4 columns. Let's set x3 as in third dimensional one. We can create the same using this randint, and let's define 10, and size you can give it by 3 dimension. That means you can set 3 values for it. Let's suppose we are setting 3, 4, 5. Okay, now let's get each one of them one by one. Let's see what we have in x1, x2, and x3. So I'm going to print x1 first, then I'm going to print x2, then sorry, x2, then I'm going to print x3. So it is like this. So you have got x1, and yeah, we have x2. The code is little bit, the output is not so great, so let me try something else to produce the output in a better way. I'm giving some new lines for it. So for the x1 we have 503379, okay, and for the x2 we have 3524, which is a 3 comma 4, right? That is a 3 comma 4 matrix. So three rows and four columns, so we have three rows and four columns. And for the third dimensional array, as you can see, it has three rows, which it has three rows, one, as in total, one, two, and three, and it has got four columns, as you can see, four columns, in the sense within themselves it has four columns, one, two, three, sorry, oh my god, I'm making a mistake. So it has got four so it has got like, so three dimensional can be defined as what you have. If I say 3 comma 4 comma 5, so you need to have three such elements. So I'm counting this as one element, I'm counting this as the second element, I'm counting this as the third element. So this justifies what we have as 3 over here, 3 over here. And now coming to the 4, now it is simply a row and a column for those elements. So 4 comma 5 is just like a row and column for those elements. So you will see four rows within each element, four rows, and you will see five columns within them, one, two, three, four, five. Same, if you go here, you will see four rows, one, two, three, four, and five columns, one, two, three, four, five. So it is easy to comprehend in this sense. So the first number defines how many elements they are gonna be, as in a total, in a cluster, how many big clusters, in if you can understand in a cluster wise, suppose these are the three clusters, so this three will represent how many clusters you have, and within each cluster how many rows and columns that you have. So four is the amount of rows that you will have in each cluster, and five columns that you will have in each cluster. That is what you need to take away from this, and this is how you can understand three-dimensional arrays. Now, coming to the next part, attributes of NumPy arrays. The first one is ndim, which represents the n-dimensional arrays, the number of dimensions. And the second one is shape. Shape represents the size of each dimension. For example, we can say a 3 cross 3 matrix, or a 4 cross 4 matrix, 4 cross 2 matrix, and whatnot. And the size represents the total size of the array, like how many elements in the array. So let's get started. We have in the previous we have created x3. So let's print x3. It was a three-dimensional array. Print x3 and see what we have here. We have a three-dimensional array. So what I'm interested in is knowing how many dimensions that it has. So I'm going to print x3 dot n dimension, and such it's the important thing to remember here is it's an attribute, not a function, so you don't need to put braces around it. It's simply, if you put braces it won't recognize, so it's not a function, it's just an attribute, so no need of braces, and just simply run the code. So you will see that it shows the dimension is 3, so we know it's a 3 dimension. Now I'm going to print the shape of the numpy array. So basically just do shape, and shape we have is 345, which we set earlier for this x3. And let's print the size of the array. So x3 dot size, and it will give us this is basically nothing but a multiplication of all these for the shape of the array. So 3 into 4 into 5, 5 into 4, 20, 20 into 3, that is 60. So this represents the number of elements within the array. The next thing we have is the data type in the array. So you can find out the data type basically by d type. D type is a attribute that you can use. So x3 dot d type, and it is showing int 64. This is the integer type data type. So that's it. And these are some of the attributes. And the most important ones are the shape and the size. The most commonly thing that you will be using in machine learning is shape and size. So do focus on that. So if you are familiar with Python's standard list indexing, indexing in NumPy will feel quite familiar then. In one dimensional array, you can access the ith value counting from 0 by specifying the desired index in square brackets, just as with Python list. Now let's create a NumPy array. So I'm gonna do np.array, and let's pass on some values. Okay, and I'm going to store in a variable named x. So I want to access the first element of the array, so I can simply do it by x, and I will put the square brackets, and I'll put 0 to it. I'll pass 0. So this is basically the indexing. The indexing starts from 0 as you know it. 0, then 1, then 2, then 3, and this is how the indexing goes. So last element is always the number of elements minus 1. Remember that. So let's print the first element. So it is showing me 1. Similarly, if you want the third element, you can simply print x, and you have 0 square brackets, which is basically for indexing, and you can use 4. And if you want the fourth element, so basically it will give you 5. So basically it's not the fourth element, it's basically the fifth element. If you count it from here, 1 2 3 4 5, so this is the fifth element. So remember, the indexing always starts from 0, and still the number of elements in the array minus 1. That's the takeaway. And you can there's also negative indexing. So let's learn about the negative indexing. In negative indexing, basically the indexing starts from minus 1. So there's no concept of minus 0. So it always starts with minus 1. So if I want the last element of the array x, I can simply do minus 1 to it, and let's see what it gives. So it gives me 6, right? Now if I want the second last element, what I'll do is x of, I'll do minus 2, and it should give me 5. And the next thing what I can do is, if I want the third element from the last, I can give x minus 3, and it should give me the third element from the last, which is 4, and it sure is giving me 4. So this is what negative indexing is. Now in multi-dimensional array, you access item using a comma separated tuple of indices. Let me explain what I meant by that. So suppose you want to create a three-dimensional array, or let's, for the sake of simplicity, let's create one-dimensional array. So x is equal to npy.array, and not even that, I can use random dot randint, and I can define a value. I want values between 0 and 9, and I can give the shape of 3 comma 2, which represents 3 rows and 2 columns, and I'm going to print x. So it is giving me 4 3 4 4 and 8 4. Now if I want to access the first element, which is 4, I can do this by x. I can do this by print x 0 comma 0, and this should work. It should give me 4. Similarly, if I want the second element in the first row, which is 3, I can do this by print x 0 comma 1, and it should give me 3, which it is giving me, so it's working. Now let's move to like adding some other value types, okay, in the in the matrix that we have created. Now suppose you want to, set the value. Let's say in this matrix only you want to set some value, for example x 0 comma 0. You want to change the value at the zeroth row, at the first row and the first column, which is 4. I want to replace 4 by, let's say, 3.25, and then we can print, and just to see if the change has worked or not, I'm going to print x, and so it is giving me 3. So what it has done, it has truncated. Since array can only store the same data type value, if you give floating point, so it will not accept the value, or it will do, it will truncate the value basically. So it will not see what is after dot, and it will just ignore this, and it will just keep the integral value, or the integer part of it, which is 3. Is accessing subarrays. So let's create another array. I'm going to call it x. I'm going to call it x and np dot array, and let's give it some values. And suppose that I want to access the first 5 elements of this array. How can I do that? How can I achieve that? So if you were familiar with NumPy slicing syntax, the standard Python syntax, which allowed you to slice Python list, which can be done by using square brackets. So x, then you have to put a square bracket, and for the first 5 elements, you just have to initially start from the column basically represents everything from the start and end it till 5, excluding 5. So this basically means that you will access 0 first, second, first element, second element, third element, fourth element. That's it. And it should give me all the elements at 0 position, 1 position, second position, third position, and fourth position. So it is happening 1 2 3 4 5. So it is giving me a total of 5 outputs, which is correct. So 0 is 1, 1 is 2, 3 is 3, 3 is 3, fourth element is 34, and fifth element is 4. So this is how sub array of array you can access of a NumPy, or normally any Python list you can access it like that. So the next one I'll do is I'll create a multi-dimensional array. The interesting part is how can you access sub arrays of multi-dimensional array. So np dot random dot rand int. I want values between 0 and 9, so I'll give it, and I'll provide the shape. I can provide it in a tuple format, so I'll give a 3 cross 4 matrix. I want a 3 cross 4 matrix. So what this code does, it gives me a 3 cross 4 matrix having values pre-filled between 0 and 9. The values will be 0 and 9 inclusive. It won't be including 10. It will be including 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's print x for this to check. Low, high, what is the value error it's giving me? So I guess it's not accepting this. So I'll provide a low value and a high value, and let's see if it works. Int object is not callable, so it's giving me a type error. So random, let me check. So yeah, I missed a comma here, and yeah, it is giving me a 3 cross 4 matrix, and it has 3755 and it's 0159. Let me zoom this for you. Let me zoom this a bit. So I have this matrix which I have is a 3 cross 4 matrix. It has 3 rows and 4 columns. The first row has 3755, 0159, 3150. So let's suppose we want the first two rows and the first two columns. The first two rows will be 3701, and the first two columns will be 37 the first two rows will be this and this 3755, 0159, and the two columns will be 303 and 710. So if I need a sub array which contains the first two rows and the first two columns, so the values will be 3 7 and 0 1. This is what I want. This is what I want to achieve, and I can achieve this by basically slicing the array. We need first two rows and first two columns, so we can use the slice notation, which is column in square brackets. So let's see how can we achieve that. X square brackets. So I want the first row and the second row, so I can do it like this. Slice till 2. Slice till 2, that means it includes 0 and 1, okay, excluding 2. So if I talk about this, so it's nothing, but it is so I'm telling that I need the first row, the first row and the second row, okay, and I don't want the third row. So indexing is like that. So 0 1, not excluding, not taking the tooth, not taking this 2, which is the third. I mean, it's it's very intimidating, when I am trying to explain it, and it is something I want you guys to understand. It's something I wish I had a marker, I could mark it down, and so if I do an indexing always start from 0. So what I'm saying is exclude 2, just take 0 and 1, and then I want to do a comma, and this represents what row I want. Now I need to specify after comma what columns I want. So I want the two columns as which is my requirement. So I'll do 2, which is 0 and 1, as in 3, the column, that is, this is the column 0, this is the column 1, and this is the row 0, and this is the row 1, and it should give me 3701 as output. So I'm running a code, and it is giving me 3701. So this is bit tricky and bit intimidating, so bear with it, just code it out. You just need to understand. Now if anyone asks you, bring me the first three rows and two columns, or the last two rows, or the middle rows, you can do it like this. So understand, so for the sake of doing it one more, let's do something complex. So what if I want this the middle last the first row and the second row, and second column and sorry, first column and second column, because I'm saying this first second as in terms of just to represent how indexing works. So in local terms, I would obviously say this is the first column, this is the second column, just because of indexing. For the sake of simplicity and indexing, I'm calling it column 0, column 1, column 2, column 3, row 1, or sorry, row 0 as in 3. This is row 0, this is row 1, and this is row 2. So my desired output that I want is this 1 5 and 0 5. So I know what I need to do. So if I want 1 5 and 0 9, 0 comma 9. So basically I need to access the last two rows and the middle columns, which I can achieve by print x, and I'll be using square brackets. So the first is I want slicing to start from the first row and until the second row. So I'll give first row and until the second row. So second row is we need, so I'll pass in 3 and or you can simply put as in not even 3. The best practice is to, if index is going out of the range, don't put it, because you want everything from that part. From that row you need from starting from that row you need every row that comes down under it, and you want those middle two columns. So for the columns you can use starting from the first column you want to until the last, you want to include this one, but you don't want to include this one. So what you can do is 0 1 2. So you need column 1 and you need column 2. So basically 1 till 2, but it will ignore 3. It's intimidating, I know it is. It's hard for me to explain also, but bear with me. So 1 column 3 is basically you will be accessing 1 and 2 only, not 3, excluding 3. So it should give me what I want, and it will give me 1 5 and 0 5, I guess. So it is not 9, it is 0 5 only. So yeah, and this is how you can achieve. I hope this is the takeaway you can get from this, and this is how you can do array sub array slicing. An extremely useful thing to know about array slices is that they return views rather than the copies of the array data. So let's understand this by one example. So let's create an array np range. Oh no, I'm going to use np dot random dot randint, then and I want the values between 50 till 100, and the shape that I want of the shape I want is 3 comma 5, and let's store it into an array as let's suppose the name of the array is x. Let's see what we have in x. So we have all these values lying between between 50 and 99. Now it has got 3 rows and 5 columns, which is perfect. Now we want a copy of it. Let's suppose I want the first 2 rows and the first 2 columns. So I'm gonna create a variable which is subview, and I'm going to store the first 2 rows and the first 2 columns in that. So I can basically do it by x slicing normal x, and I want the first two rows and the first two columns. So let's see what we have in our sub view. So 99, 86 and 53 and 84. Now suppose I want to change 99 by 100. So I can do this sub view. I can access the element at 0 comma 0, which is 99, and I want to change this value to 100, and I'm going to print what is, if the sub view has changed or not, if the value has changed at the first row and the first column, which is 99 here, whether the value has changed or not. So yeah, it has changed. Now let's uh, the best part is to check whether the value has changed into in the original array or not. In the original array, the name of the original array was x, so let's print x, and the important point to note here is the value has definitely changed. So it doesn't return a copy, and it actually shows you the view when you do a slicing, sub array slicing, or any kind of slicing onto the numpy array. So this is what you need to take away. Create copies of the array. So the heading would be creating copies of the array. Suppose you don't want the original array to change, so you can use the copy method. So what you can do is I'll use the last code only to represent what I'll do. So we have a sub view. I'm just gonna copy the code from here, and what I want to do is I've got the sub view. Now I'll just do this copy method. I'll apply a copy method onto it, and I'm gonna change the variable. Okay, change the variable. I would love to call it a copy, sub view copy. And now if I do the manipulation on the sub, let's first see what we have as in copy, sub view copy. So it is still 100. Now if I want to change 86 to some values like 99, what I can do is I can use sub view copy, and I can use 0 row, and this is the first column, as I'll set the value to be 99, and I'll print the sub view copy to see whether it has changed or not. So yeah, it has changed, but let's see, the main part is to see whether it has changed in the original array or not. So let's see, print x, the original array was x, so it is not changed, so it has not changed, it is still 86. But by using dot copy method, you have basically created a copy of that particular sliced array, and there if you want to do manipulation you can do, so that it will not affect your original array. The new topic we have reshaping of arrays. Another useful type of operation is reshaping of arrays. The most flexible way of doing this is with the reshape method. For example, if you want to put the numbers 1 through 9 in a 3 cross 3 grid, you can do the following. First, let's do grid is equal to np.arrange, and you can do it, set the low value and a high value, and simply just do the just call the reshape method, and the shape that you want is a 3 cross 3. Remember to put it in brackets, and this will give you the 3 cross 3 grid that you need. It's just connecting right now. It will take a little bit of time. Just bear with me, and it should give me the output. Yeah, NP is not defined just because I haven't imported. So import numpy. Remember to always import your dependencies. Import numpy as NP, and now run it, and it will work. Now let's print grid. So remember, you can always do a reshape of one dimensional or two dimensional arrays unless and until it matches up with the number of elements that you have in the array. For example, if I want to reshape with, if the multiplication doesn't add up to 9, let's suppose we have got 9 elements, okay, and I want to reshape grid dot reshape, and I want to do a reshape. Let's say it should not multiply, the multiplication should not yield 9, it should yield something else what we don't have, like 3, that reshape like 4 comma 3. So the number of elements that I need to have in the grid should be 12 for it to work, but it will not work because the number of elements that we have in the grid is only 9. So it should throw me an error. So value error, cannot reshape array of size 9 into shape 4 comma 3. Concatenation and splitting. Concatenation or joining of two arrays in NumPy is primarily accomplished through the routines of np.concatenate, np.vstack, and np.hstack. np.concatenate takes a tuple or a list of arrays as its first argument. Let's see how can we concatenate. So I'm gonna declare a variable which is x, and I'm gonna call np.array. So I need to import numpy as np. So x is equal to np.array, and I'm going to pass one array, let's say 1, 2, and 3. And the second is, let's declare another variable which is y, which will have some other values in it, np.array. Let's say 4, 5, 6. So we want to concatenate these two. We can use np.concatenate method. And we need to pass these two values in a form of a list or a tuple. So I'm gonna pass it in a list form, which is x comma y, and let's see what we have. So we have an array which says 1, 2, 3, 4, 5, and 6. So the values within x and y are copied into a single array, and all the values are displayed accordingly. Now np.concatenate can also be used for two-dimensional arrays. For example, grid. Let's say we have a grid is equal to np.array, and I am going to use 2, 1, 2, 3, and 4, 5, 6 as demonstration. Now suppose we want this grid to have another, like same, we want like these to be repeated, these two elements of matrix to be repeated in the same, like we want to concatenate grid with the grid itself. We can do so in np by calling np.concatenate and pass two values in list, which is grid comma grid. Let's see what we have as our output. So there you go, we have our output as 1 2 3 4 5 6 and 1 2 3 and 4 5 6. So for working with arrays of mixed dimensions, it can be clearer to use np.vstack, which is also known as vertical stacking. So first is np.vstack, and the second is np.hstack. So let's understand one by one using np.vstack and np.hstack. np.hstack is also known as horizontal stacking, and np.vstack is known as vertical stacking. So we have one variable which is x is equal to np.array. I'm going to call it 1 comma 2 comma 3. Now let's say, suppose we have a grid which contains these values 987 and 654. Now let's stack these two. Now let's do a vertical stack. So we can use np.vstack and pass these two values in a list form. First x, then I want the grid, and let's see what is the result. So we have got 1 2 3. This is at the top, and rest other is at the bottom, which is 987 and 654. Let's do a horizontal stacking. Suppose we have another variable which is y, which contains 99 as values. And let's say we have another one which is 99. So I can do a horizontal stack by np.hstack by calling hstack, and I'll pass these two values in the form of list, which is y and the grid that we earlier made. And let's see what is the output. So we have a horizontal stacking of 99 and 99. Then we have vertical stacking of this 987 and 654. The opposite of concatenation is splitting, which is implemented by the functions np.split and np.horizontal split and np.vsplit. We'll use these methods one by one. For example, let's do this. Do code with me, okay? X is equal to 1 2 3 4 5 6 7 8. All right, now suppose I want to do a split using some splitting and using some splitting points. Suppose I want x1, I want to do 3 splits, okay, x3. So I can do np.split, and I will pass what to split and where to split. So in where to split, I can use, like, I want the first 3 same, so I can do it like split after 3 and split after 5. So let's see what we will get. So we have 1 2 3 4 5 6 7 8. Notice that n split points lead to n plus 1 subarrays. The related function np dot h split and np dot v split are similar. Okay, so let's do another one for np dot v split. So in this case, what I'm gonna do, I'm gonna create a grid, and I'm gonna do an np dot a range on this, and I'm gonna put in 16 numbers, and dot I'm going to reshape just to make a 2D matrix, and I'm gonna reshape into a 4 cross 4 matrix, a square matrix to be precise, and I'm going to call the grid. Let's see what we have. Now I want to vertically split from the second position. For example, I want 0, 1, 2, 3 and 4, 5, 6 into a single split, and 8, 9, 10, 11 and 12, 13, 14, 15 into another separate split. So I can achieve this by, I'm going to call two functions, that is upper and u short for upper and l short for lower, and I'm going to call np dot v split on what I want to split, on grid I want to split, and I want to split from the position 2. Okay, so let's see what we have. I'm going to print u, and I'm going to print l, and see, we have here what we wanted. So I'm going to print these two separate so that you don't have a problem understanding what we have done. Print u and print l. So let's see what we have. So we have got two separate splits, and the split is done on the basis of the index that we have provided from where to split, as in from what row to split. Okay, so we have provided the row from where the vertical splitting should be done. Okay, the same goes with h split. So what we can do is, like, let's do a one left and right, and we can do a np dot h split, and we are going to do this split on a grid, and from the column 2 I want to make this separation, or I want to make this split, and I'm going to call left and right. Let's see what we have. So we have two splits. Okay, left and right. I guess it's not coming right, so I'm gonna beautify my code, as I would call it. Print left and print right, just to see how, just to analyze our code better. So we have got two horizontal splits. So the grid, for the reference, I'll print the grid also. Grid and backslash, and this line will give me a new line after the code runs. So sorry, not this, it should be a backslash. So it's like this. So what I have is, from the column 2 I want to make a split. So this is column 0, this is column 1, and this is column number 2. So this is where the splitting has been done. So one split is 0, 4, 8. We have 0, 4, 8 and 12, and 1, 5, 9, and then another one that horizontally, that is it has split, is 2, 6, 10, 14. We have 2, 6, 10, 14, and we have 3, 7, 11, 15, and we have 3, 7, 11, 15. So from the column 2 it has split as required, as we have given in the code over here. So these were the type of splits that you can do using Numpy. Exploring Numpy array arithmetic. In array arithmetic, we can go on about addition, subtraction, multiplication, division, floor division, negation, etc. So let's understand all of them. First, let's create a variable using arrange method, and this will give you from 0 till 3, 0 1 2 3, and let's print it out. So it's giving me 0 1 2 3. Now let's do addition. Let's suppose we want to add 5 to every element in the list, in the array. So adding 5 results to 5 6 7 8 to every element, and this is also a part of broadcasting. We will also discuss this later on. Now let's do subtraction. So we can do like print x minus 3. Let's see what's the result. So minus 3 minus 2 minus 1 and 0. Now what we can do is let's multiply. So we'll multiply it with 10. So x into 10 and see what's the result. So every element in the original array of x is multiplied by 10. Now coming to division, we can also divide, right? So print x divided by 2. Let's see what's the result. So it is 0. Now everything is converted, like upcasted into a decimal. In a floating point integer we have. So upcasting is also done internally by Numpy arrays. And the next thing that we can do is we can do a floor division. Print x, and you have 2 backslashes and divide by 2. So you get 0 0 and 1 1. So it gives an absolute floor value of that number. Absolute floor value of that number when you divide that number. And whatever is the result of that division, it gives you a floor value, the lowest possible value of it. So next, moving on, there is also arithmetic operation for negotiation. So let's understand negation. My bad. So negation, I can do a print of minus of x, and it should give me a negation of what I have in the original x. So 0 minus 1 minus 2 and minus 3. Now I can also do exponentiation. So let's understand exponentiation and how does it work. So what I'll do, I'll print x, and I want every element to get squared in that array. So let's see. So yeah, it's giving me a square of every number which was initially present in the array x. Now let's do a modulus. Modulus basically gives the remainder when you divide that number. So let's print x modulus 2, which basically gives the remainder when you divide this number by 2, and let's see what's the result. So it's a 0 1 and 0 1. So that's it for the array part, for the array exploration and array arithmetic. Now next we will discuss about absolute value. So let's understand absolute value and how it is used. So absolute value, just as NumPy understands Python built-in arithmetic operator, it also understands Python built-in absolute value functions. So let's say we have x is equal to np.array, and we have some numbers in it, minus 2, minus 1, 0, 1, 2, let's say, and what we want is absolute. The absolute value basically gives you positive integers of that number. So what I can do is I can do an absolute x, and I'm gonna store the result into some variable, let's say result, and let's print result. And we will also check if the original array is modified or not. So let's see. So while printing x, we get the original array, which is -2, -1, 0, 1 and 2. But now with printing of the result, we get 2, 1, 0, 1 and 2. So absolute gives you the positive, returns the absolute value of the argument basically. As I'm hovering over, so it is telling me, so what does it return? So it gives you the absolute or the positive value of that number. So minus is converted to positive. That's it. That's all you need to understand. And these numpy arrays are also very powerful powerful functions, that it can handle also trigonometric function. For example, let's start with trigonometric functions. Suppose we have theta is equal to np dot linear spacing. So len space basically provides a linear spacing, okay, between a certain range of numbers. So a len space of 0 till np, which is numpy dot pi value, which is equal to 3.14 comma 3. So it gives me how many numbers do I want. And let's see what we have in theta. Let's print theta, what we have as theta. So in theta we have three numbers, okay, three numbers, which is 0, 1.57 and 3.14. So what it has done, it has linearly divided 3.14 into three values, three equal spaced values, okay. So let's understand the how trigonometric functions work with it. So print, let's first see with what is theta, we know. Now let's do sine on it. So print sine of theta, and it should give all the sine value associated. Sorry, np, we need to do np dot sine. Don't forget to use np, as we are using this library, numpy library, so don't forget that dependency. So it's giving me the value of 0 and 1 plus e, so which is correct. It's giving me the right value of the sine theta. Now similarly we can do a cos value with it. Print np dot cos, and you can do your theta. So it's giving me all the cos theta values of these three elements in the original theta array. And similarly you can do a tan or a cos. Cos we have done, sine we have done, we can do a tan. So cosec can also be done, and everything related to trigonometry can just this was just a basic showcase just for you to understand that the library is really powerful. So it can handle, it can also handle your trigonometric functions. So no need to worry about that. If your future work requires to have trigonometric functions included in your program, then to numpy is the best suitable answer for you. And we can also use it on logarithms. So exponents and logarithms, we can do that. So let's try with exponents and logarithms, logs. So let's say we have x is equal to some list 1 comma 2 comma 3. Now what we can do is print x. We know what is x, so I'm gonna print so that you can see in the output, which is 1 2 3. Now I want to do an exponent of e, okay. So what I can do is np dot exponent exp. For the exponent we use exp, and in that I'm going to pass x, so it will give me an exponent e to the power 1, e to the power 2, and e to the power 3. So it will give me the value of 2.7, which is correct, 7.3 and 20.085. Now similarly we can do is 2 to the power x can also be done in this fashion. In this way, print np dot exp, and you need to provide 2 with it, and in the bracket you have to pass x, so it will give you 2 to the power of x, which is 2, 4 and 8 of the original array. The original array was 1, 2, 3, so it is giving you the values. So now let's move on to, we can also do a power function in this. So let's use print np dot power, and we can use 3 comma x, so it will provide you 3 raised to power x, the value of 3 raised to power x. So just to represent, it will give you something like this. So let's see what we have. 3 to the power x, we have 3, 9 and 27 for all the values corresponding to x. And it is 2 to the power 3, so for the exp2 it showed me what is 2 to the power x, which I can represent as like 2 power x. So 2 to the power x of the original array, so 2, then we have 4, then we have 2 to the power 3, which is 8, so which is correct. So now we can also do a log on the original array. So what we just need to write print and np, just call the library, call the function np.log, and pass in the original list or the array that you have, and it will give you a logarithmic value of the original array x. And that's how you can do. And any more calculations that are required in the numpy library can also be done, and you can also go through the documentation of the numpy library just to read more and understand. After this we will move on to pandas, and we will understand pandas in our next session.